All right, special right triangles video number 2. We're going to talk about the 30, 60, 90 ones here. So here's a 30, 60, 90 right triangle. Notice I've already put some side links on that. You could check these with the Pythagorean theorem. But basically this right here is what I try and memorize. For the 45, 45, 90s, I really didn't talk about that one to memorize. But the one that I memorized for the 45, 45, 90s is with the two legs are both 1, and then the hypotenuse is square root of 2. We talked about this being 1 times the square root of 2, whatever the legs were. So this is the one I memorized here. Sorry, I thought it was ready. But let me show you a couple ways to do this. And you can actually do the 45, 45s, 90s both ways as well. But I'm just going to show you another way to approach these if that first way didn't make sense. So with these, you could memorize kind of like what I was doing if you should multiply by square root of 2 or divide by square root of 2 with the 45, 45, 90s. On this one here, you always have a short leg. Okay, so you always have one leg, and by leg I mean it's a side of the triangle that makes up the 90-degree angle. This is the hypotenuse, and the other two are legs. So you always have a short leg, you have a long leg, and you have a hypotenuse. Okay, the short leg and the long leg always have a specific relationship. Okay, how does 1 compare to 2 when we think about multiplication wise? Okay, well, 2 is twice as big as 1, or you could say this is half of the hypotenuse. Okay, so you always have that relationship. So that makes it pretty easy whenever you encounter a new 30, 60, 90. If I tell you that this side is 8, the short leg, well, the hypotenuse is just double that, 16. Okay, or if I had told you the hypotenuse was 14 square root of 7, just picking another number, this is half of that, 7 square root 7. Okay, it's half of that value. All right, so that's probably the easiest relationship. The one that's a little more tricky is the relationship between the short leg and the long leg. Okay, this is multiplied by the square root of 3. So whatever the short leg is, if you take it times square root of 3, you'll get the long leg. If you were given the long leg, you would just divide by the square root of 3 to find the short leg. Okay, so if I take another one here, just change the way it looks a little bit once in a while so you guys don't get too comfortable in just the one way of looking at it. If I told you that this was 6, this short leg, you'd recognize short leg is across from the 30-degree angle. And if I wanted to find the long leg, all I'd have to do is take that short leg and multiply by square root of 3. Or for the hypotenuse here, I would just have to double it. Right? That's what we talked about before. So not too bad, hopefully. But it does get a little trickier as you get into some problems. What if I told you that this long leg was 10? What would you do to find the short leg? Well, you would find the short leg by taking 10 and just dividing by the square root of 3. Okay, that's the relationship between those two sides. But you wouldn't leave it like that because we know that we rationalize denominators where a square root is. So we'd take a times square root of 3 over square root of 3 and get 10 square root 3 over 3. That would be our answer. You're going, oh, that's ugly. Well, a little bit, but it's not too bad. And then to get the hypotenuse, we just take this and double it. Well, that times 2 just makes 20 square root 3 over 3. Okay, so that's kind of the way that I showed the last video as well as this one here. It's kind of memorizing these rules. Okay, but for me, if I can remember this picture, I can figure out the rules from the picture. And some of you might be able to do that too. I think that's the easiest way if you can do it. Okay, now not everyone can remember those rules, and that's fine. So here's another approach. This is maybe what some textbooks will teach a little more often. It's a little more concrete way of doing it. So what they're going to do is they're going to give you this picture of your 30, 60, 90, and they're going to say they're going to have these 1, 2, and square root of 3 things there as well, but they're going to have an x with all of them. Okay? And so what they're doing is they're playing off of the idea, and my approach does this as well, but plays off the idea that all 30, 60, 90 triangles are similar. They're similar because of the angle-angle similarity theorem. If two angles of a triangle are the same, those triangles are similar. And we learned that similar triangles have proportional sides in equal ratios. So that's what they're trying to do here with these x's. They are just scaling these sides by a specific value, making it bigger or smaller. If this x value were bigger than 1, this triangle gets bigger. If this x value were between 0 and 1, it's going to get smaller. Okay, it's just scaling it, and that's something we've studied. So hopefully that makes some sense to you. So if you came across a problem that said, all right, how do I want to do this? Here is your third, and they're going to have these in different, orientations, so you might have to rotate it, those kinds of things. But let's say this was your triangle, and let's say they gave you this side right here to be 7 square root of 2. I'm going to do a hard one here, just so you guys see how this works out. So you're going to look at this and you're going to say, okay, 7 over square root 2. First off, I got to recognize that that's the hypotenuse, right? And what you're going to do is you're going to just take that hypotenuse and you're going to make it equal to the hypotenuse over here, okay? Now the reason you don't have to make a proportion right now is because they've already built that in with this x, okay? And so that's just going to equal the 2x. So if you want to solve for x, just divide by 2. And so 7 square root 2 over 2, that's going to be your x. Boy, I just sounded like Khan Academy in that for a second. That's weird, sorry. So 7 square root 2 over 2 is your x. That's going to go where the 1x was. So 7 square root 2 over 2 is that. And again, recognize that's just half of the hypotenuse, right? 7 square root 2 divided by 2. So we talked about that relationship, but this was a form, or I should say a process, using a formula to get that. And now here, if we want to figure out this, all we have to do is, once we found our x, we just have to plug that x in for that. And so we get 7 square root 2 over 2 times square root 3 right there. And you're going, oh boy, that's kind of scary, but well, we can do that. Square root 2 times square root 3 is square root of 6. So we have 7 square root of 6 over 2. The 2 cannot cancel with the 6 because that's under a radical and the 2 is not. So that's it. That's this side, that's that side, and that's what they give as the hypotenuse. So you can do this for 45, 45, 90s as well. It's just another way of doing it. So practice, 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 guys. Get your questions to me. We're going to do this today, Tuesday, tomorrow, Wednesday, and then we're going to take a break for a little while for Easter break. All right, thanks, guys.